In 2012, Forbes.com's Kashmir Hill described to us the situation of a girl whose father had found out she was pregnant because of maternity advertising she had received in the mail. In 2013, Google incorrectly identified the spread of a deadly flu virus in the United States. How in the world do companies like these begin to make these kinds of predictions? The truth is, retailers keep large collections of information about many of us. Target had determined the girl was pregnant based on some shopping patterns she exhibited. Google had used a previously developed algorithm that they had based on search term prediction, but this was heavily influenced by a recent flood of news stories, and that's caused the incorrection. Both of these scenarios suggest that we leave behind a lot more information as we go about our day-to-day business than we really intend to. What we're talking about is big data and data mining. As an applied mathematics student, I am heavily interested in this area of research. By exploring what big data is and the ways in which it is used, we can see how big data is changing the way we look at things in the world through the analysis of information we leave behind us. First, we'll look at what big data is, and secondly, we'll see how it is deciphered and used today. First, let's explore what big data is. First and foremost, big data is a large amount of information that can come from a wide variety of sources. Stephanie Hampton and Company, in their 2013 paper, Big Data and the Future of Ecology, give us a good working definition. Big data generally refer to massive volumes of data not readily handled by the usual data tools and practices, and present unprecedented opportunities for advancing science and informing resource management through data-intensive approaches. What we get when receiving raw data is massive volumes of information, often with millions of entries. In their article for Foreign Affairs, The Rise of Big Data, Cukier and Schoenberg help us refine this definition a little bit further. Given this massive scale, it is tempting to understand big data solely in terms of size. But that would be very misleading. Big data is also characterized by the ability to render into data many aspects of the world that have never been quantified before. Call it datafication. For example, location has been datafied through first longitude and latitude, and then through GPS coordinates. We've even been able to datafy our friends through services like Facebook and Twitter. We leave behind lots of this information, but a lot of this is generated from online activity and shopping. That's where the bulk of the information comes from. Now that we've looked a little bit at what big data is, let's discover a little bit about how it's interpreted, how it's used, and what it means to us today. The analysis of big data is more properly called data science. It's an area of intersection between statistics and computer science. Data is analyzed by statistical methods employed by computers. In the 2013 journal article, Looking Back at Big Data, an historian explains why computers are an indispensable resource that's perfectly suited for this task. Computational history is a complement to the historian's work. How many documents can a historian read each year? Machines can scan a much larger amount of content and find connections. These methods are also frequently used in things like market analyses and business management to increase efficiency. While not yet perfected, data science is changing the way the world looks to us and brings its own issues along for the ride. In the 2014 journal article, Data on Demand in Engineering and Technology, the author points out some of the privacy concerns involved. Through its reliance on existing data and predictive analysis to create detailed individual profiles, big data has exploded the scope of personally identifiable information. It has also effectively marginalized regulatory schema by evading current privacy protections with its novel methodology. Most of the data that's gathered is used in an anonymous manner, and there generally isn't any real concern about your own personal information being leaked, although this can happen in some odd scenarios. As Alex Pentland points out in last October's Scientific American, this data is more than anything else a necessity. Such uniquely 21st century problems demand 21st century thinking, yet many economists and social scientists still think about social systems using Enlightenment-era concepts such as markets and classes, simplified models that reduce societal interactions to rules or algorithms, while ignoring the behavior of individual human beings. We need to go deeper to take into account the fine-grained details of societal interactions. The tool known as big data gives us just the means to do that. One particularly relevant example to this is online advertising, where now sites like Google and sites that use Google's programs have created uniquely tailored advertising that's focused specifically on you. So I hope you've kind of come to see now that big data is a topic which is not only of great importance, but is also important to each of us in the way that it personally affects us. We've explored what big data is really made up of, mostly the information about us and what we do. I explained briefly how this data is given meaning, and last we observed a little bit about how this affects us every day. Every time you click or check out, remember that a little piece of that will go toward building tomorrow. What about the girl and her father we saw earlier, though? When the manager of their local Target store had called to apologize, the father instead apologized to the manager. The girl was indeed pregnant. Big data is changing the way the world looks to us, as people in business, advertising, as consumers, or just as people. So let's keep that in mind as we continue around in our day-to-day business and leave behind our little breadcrumbs.